Hey there, how are y'all? We are going to be looking at 5.6 today on solving radical equations. If you notice in the book, you'll see some problems and examples on solving radical inequalities. That is not a standard for Algebra 2, and so we'll be skipping those for today. All right, so our objective is going to be canceling this out because I forgot to erase it, but it'll be to solve equations containing radicals and rational exponents. And so our standard AREI 2, solve simple radical and rational equations in one variable and understand how extraneous solutions may arise. And so we're going to talk about those steps now. And solving radical equations is no different than solving any other type of equation. We have to think about our order of operations, PEMDAS, right? And remember that when we're solving an equation, we work backwards. We get rid of addition, subtraction first, then multiplication, division, exponents, and finally parentheses that may be involved. Now, how does that work with a radical equation? Well, we have this exponent step, and remember that radicals are exponents, because remember we could write like the square root of x is the same as x to the 1/2 power. Go back to Algebra 1 for those. Or we could write the cube root of x is equal to x to the 1/3 power, right? And we see that when we looked yesterday with square root and cube root functions. All right, so step one is to isolate the radical on one side of the equation. So if there's only one radical, we want to get it by itself first. Step two would be to raise each side of the equation to a power equal to the index. And remember, the index is the number in the hook of the radical. So that we cancel that power out. And then step three, solve this new polynomial equation and check your result for extraneous solutions. And we'll talk about that last little bit when we see it in an example here in a few moments. Now, let's talk about this first example. So here we see the square root of y minus 2 minus 1 out back is equal to 5. And so remember, step one said to get the radical by itself, and so my first step will be to add 1 to both sides of this equation. And so I get the square root of y minus 2 is equal to 6. Now, you're probably asking yourself, there's no number in the index, it's just a square root. Well, remember that we could have a 2 here, and so that means we're going to square both sides of this equation. And when we square both sides of this equation, we're going to get the y minus 2 because the square root is canceled by the square, and that's equal to 36. We add 2 to both sides, and we're going to get that y is equal to 38. Now, we want to always check our solutions to make sure that they make sense to the problems that are involved, because especially with square roots, you remember that the value under the radical cannot be negative if we're finding real solutions. Well, this is equal to a real number, so this better come out real as well. And if we check that answer, 38 minus 2 under the radical minus 1, is that equal to 5? Well, this would be the square root of 36 minus 1. Again, still asking ourselves out. 6 minus 1, is that equal to 5? Of course it is. So this answer does check out. Y is equal to 38. So let's look at a second example here. This one's actually a little bit easier. There's nothing outside the radical. The radical is already by itself. The square root of x minus 12 is equal to 2. So in this problem, what are we going to do first? We're going to square both sides. And so when we square both sides, we're going to get x minus 12 is equal to 4. And when we add the 12 to both sides, we get that x is equal to 16. Now, again, think about what could go under here. The whole part under the radical must be positive, not just the value of x. X could be negative in certain situations. But let's check our answer. 16 minus 12, is that equal to 2? Square root of 16 minus 12. And so the square root of 4, is that equal to 2? Of course it is. So this checks out, so this is my final answer. So again, we haven't had any extraneous solutions yet because the answer that we have found has been the solution to the problem. But let's look at example 3 here. This example is a little different. What do you notice about it? Well, there's a radical on the left-hand side, and there's also a radical on the right. Now, our directions say get the radicals by themselves. Well, you can't do that when there's more than one. And so our first step here is to isolate one of the radicals. Now, I could isolate the one on the left or the one on the right. It doesn't matter which one I isolate, but we've got to isolate one of them. And so I'm going to square both sides as my first step. And so we're going to get x plus 5 is equal to what? Now, you're probably tempted to just say 16 plus x, because you square the 4 and you square the square root of x and you get 16 plus x. But remember, that's a binomial, so we have to multiply it out. It's 4 plus the square root of x times 4 plus the square root of x. And so 4 times the 4 is 16. 4 times the square root of x is 4 root x plus 4 root x. And then square root of x times square root of x gives us just x. And so it's going to give us 16 plus 8 square root of x plus x. And so let's put that here. And so now we've gotten this equation. Now let's see what our next step would be. Well, now I've got one radical, and I've still got to get that one radical by itself to get rid of that radical so I can solve this whole equation for x. So let's start solving to get this radical by itself. So I'm going to subtract x from both sides. That cancels, and that cancels. Ooh, that's kind of interesting. Let's see what happens next. So 5 is equal to 16 plus 8 square root of x. I'm going to subtract the 16 from both sides. And so I get negative 11 is equal to 8 square root of x. And then I'm going to divide both sides by the 8. And I get negative 11 eighths is equal to square root of x. Now, it's not a pretty number. It's negative 11 eighths is equal to square root of x. It's not terrible. We've dealt with a lot worse. But let's see what happens next. What would be my next step? Well, it would be to square both sides, right? So if I square the left, I get rid of the square root. Square the right, we're going to get 121 over 64 is equal to our x. So the question becomes, is that what solves us for x? Well, let's think about this for a second. Look at this line right here. I have that the square root of x is equal to a negative. Can that be true? Well, the only way that's true is if I'm dealing with an imaginary number, and with these problems, I'm not dealing with imaginaries, right? And so if we test this answer, watch what happens. 121 over 64 plus the 5, is that equal to 4 plus 121 over 64? And so let's see what we get. This needs to convert to something over 64, and so 64 times the 5 is going to give us 320 over the 64. And so 4 plus square root of 121 is 11, square root of 64 is 8. So this is going to give us the square root of 441 over 64. And this is going to give us 32 plus 11. 32 plus 11 is going to be 43 over 8. And the square root of 44 is 21 over 8. So does 21 over 8 equal 43 over 8? It does not, so it doesn't check out. So this answer is actually not valid. And so in the end, this problem has what? No solution. And so what we have found here is what we call an extraneous solution, because we did the math right. Everything we did at the top lines here, all this is right. But the problem is that the answer does not actually make a valid solution. We see that over here, it does not give us the same on the left and right side of the equation. And so that is an extraneous solution. Now, in this case, we get no solution. Other problems that we solve, we might see it come out to where we get two solutions because the answer comes out quadratic when we do our work. Like up here at this first step, these x's may not have canceled. And maybe this was 2x and this was x, and so we subtract and we still have an x. And when we square that, we get a quadratic. And one of those solutions may not work. Both those solutions may not work. It just depends on what values that quadratic gives us. So let's look at some problems that aren't square roots. So let's look at this problem. It's a cube root equation. And like we talked about before, remember that cube root equations could show up as either with the cube root with the index, or we could end up with a power here. And so we're going to use the same steps. We're going to get this radical, or in this case, the rational exponent by itself, and solve from there. And so we're going to get the 3y plus 1 to the 1/3 power, because we're going to subtract 5 from both sides, and so we're going to get the negative 5 over here. And then to undo this rational power, remember that we're going to raise it to its inverse. So if I have the 1/3 power, I'm going to raise it to the 3rd power. If I have the 2/3 power, which again, those are rational equations that we could be looking at, and we will if we had the chance to get to them before the end of the year. But the steps aren't any different here. So again, we would take this inverse power. And so this will cancel this, but remember, I also need to do it to the other side of the equation, because remember, what you do to one side, you have to do to what? To the other. And so we're going to get 3y plus 1 is equal to negative 125. Because remember, negative 5 times negative 5 times negative 5, right? So I'm going to subtract 1 from both sides. And so I'm going to get that 3y is equal to negative 126. We're going to divide both sides by that 3. And when we do that, we're going to get negative 42. And so we still need to check for extraneous solutions with cubic functions, but they are less likely to happen because cube root functions have a domain of all real numbers and a range of all real numbers. And so the likelihood of an extraneous solution happening is less for cube roots than it is for square roots. And so we'll check this answer out. So 3 times the negative 42 plus the 1, all that to the 1/3 power, plus the 5, is that going to all cancel out and give us 0? And so we check it out. We've got multiplication here, so that's going to give us a negative 126 plus the 1 to the 1/3 power. And so that's going to give us negative 125 to the 1/3 plus the 5. The 1/3 power of 125 is 5, so it's going to be negative 5 plus the 5 is equal to 0, so 0 does equal itself. So y is equal to negative 42. All right, so again, the steps aren't any different from what we did for square roots, it's just that we're dealing with a different power here. Okay, so example B here, we've looked at 4 examples. Let me get you to pause the video here, and I want you to try this one on your own. This one's very similar to the example A that we just did. So pause the video and see if you can get what I get. All right, I hope you tried it out, and so let's look at this problem. First step is that we're going to add that 3 to both sides and get 2y plus 1 to the 1/3 power is equal to 3. Now, are these problems always equal to 0? No. These two just happen to be. So let's continue through. So now we're going to raise both sides to the 3rd power. And so we're going to get 2y plus 1 is equal to 27. Careful that it's not 9 here. 3 times 3 times 3, right? Minus the 1 from both sides. So 2y is equal to 26. And we're going to divide both sides by the 2 and get y is equal to 13. And so we check that answer. 2 times 13 plus the 1 to the 1/3 power minus 3, is that equal to 0? So 2 times 13 is 26, plus the 1 gives us 27 to the 1/3, minus the 3, still equal to 0. And so 27 to the 1/3, so what is the cube root of 27? That is 3, minus the 3, and that does give us 0. It does check out, so y is equal to 13. So again, make sure you do your check work as well, because again, we do need to see if we have extraneous solutions. Like I said, with cube roots, it is not as common, but it does happen every once in a while. All right, last example we're going to do here, we're going to solve this problem here. 7 times the 6th root of 5m plus 4 minus 4 is equal to 10. And so let's look through these steps here. Again, think about PEMDAS as we do it. What do we need to get rid of first? We need to get rid of addition subtraction. So we're going to add the 4 to both sides. So I'm going to get the 7 times the 6th root of 5m plus 4 is equal to 14. I'm next going to divide both sides by the 7. And so I'm going to get the 6th root of 5m plus 4 is equal to 2. My next step would be to take both sides and raise it to the 6th power, because again, we want to get rid of this index. So I'm going to get 5m plus 4 is equal to 64, because 2 times 2 times 2 is 8, and another group of 3 2's would give me another 8, so 8 times 8 is 64. And solving from here, that's not the button I wanted to hit. Solving from here, we're going to subtract the 4 and get 5m is equal to 60, and divide both sides by the 5, so m is equal to 12. So again, just like square roots and cube roots, we do need to check our solutions just to make sure they are true and not an extraneous solution. And so we're going to get our 7 times the 6th root of 5 times 12 plus the 4 minus the 4 equals to 10. We'll check all that out. So 7 times the 6th root of 60 plus 4 minus the 4 equals 10. So 7 times the 6th root of 64 equals 10. And the parentheses aren't really required here. It's just helping us keep everything organized. And so the 6th root of 64, so what times the self times the self times the self times the self times the self, we give us 64. That is 2. And so 14 minus the 4 does give us 10. And so our solution is that m is equal to 12. And so that's it for this lesson. You're going to see a couple of word problems at the end of this assignment, but it's still the same idea that you're solving these equations for the variable in them, or you're needing to substitute into those to verify values that come out. So that's it. Again, if you have any questions, don't forget to hit up that Google Meet and send me that email. So y'all have a great day. And the word of the day is... let's make the word of the day hump day. As I said, hump day, because it is Wednesday. So y'all have a great day.